Welcome to another video on factoring trinomials when the leading coefficient a does not equal 1. This video shows how to factor trinomials using a method called bottoms up. The method of trial and error and grouping are covered in another video. So the main purpose of bottoms up is to transform a quadratic in this form to one where the leading coefficient is equal to 1. Let's go ahead and take a look at the steps and an example at the same time. Step 1, we multiply a times c and rewrite in the form of x squared plus bx equals ac. So for this problem, we would rewrite this as x squared minus 11x, and then the constant term would be 12 times 2, which would give us 24. The next step is factor as we normally would by finding the factors of the constant term ac that add to b, the coefficient of the x term. So for this problem, we want to find the factors of positive 24 that add to negative 11. That would be x minus 3 times x minus 8. The next step is we divide the constants in each binomial factor by the original value of a. The original value of a was 12, so we divide this 3 by 12, and we divide the 8 by 12. Next, we simplify the fractions that we formed. So 3/12 would simplify to 1/4. So this would be x minus 1/4. And 8/12 would simplify to 2/3. The next step, if the simplified fraction does not have a denominator of 1, move the denominator to the coefficient of the variable. So what we have to do here is take this 4 and move it to the coefficient of the x, and the same thing with this 3. We move it to the coefficient of the x. And this will be the factored form of the original polynomial. So in factored form, we would have 4x minus 1 times 3x minus 2. And you can see the first terms are the factors of 12x squared, and the last terms are the factors of positive 2. And our inner product and outer product do give us the middle term, so it checks and we have it factored correctly. So it is a very nice technique to rewrite what can be a challenging trinomial into one that most of us prefer, where the leading coefficient is equal to 1. Let's try a couple more of these. Don't forget though, whenever we factor, we should always look for a common factor first. There isn't one here, so we will multiply a times c. 15 times negative 6 will equal negative 90. So we write this problem as x squared plus x minus 90. And we factor this as we normally do. We want to find the factors of negative 90 that add to positive 1. That would be a positive 10 and a negative 9. So we write down plus 10 and minus 9. Now we don't want to stop here. Remember, this is not the original problem. We're dealing with this problem here. So the next step is we divide the constants by the original value of a, which was 15. And then we simplify these fractions. So we'd have x plus, this would be 2/3, and this would be x minus 3/5. So now we take the denominators of the constant terms and move it in front of the variable x. So going back to our original problem now, this is all of our work. In factored form, this would be the same as 3x plus 2 times the quantity 5x minus 3. And you can go ahead and check that, but it does check. Let's go ahead and try another. Now again, if we get in a hurry and multiply 2 times 96, we'll have made an error because 2 is a common factor among these three terms. So when we factor the 2 out, we're left with x squared minus 14x plus 48. And we can see that the inner trinomial has a leading coefficient of 1. So for this problem, we do not have to apply bottoms up. We can factor this as we normally would, where we put the factors of x squared in the first positions and try to find the factors of positive 48 that add to negative 14. And with some trial and error, we would come up with a negative 8 times a negative 6 will give us positive 48, and also add to negative 14. So you got to be careful. Always look for your greatest common factors before you jump into one of the other techniques. Okay, let's try another. On this problem, we do have a common factor of 3, so let's factor the 3 out first. However, the inner trinomial still does not have a leading coefficient of 1. So when we finish, we know we should have something that looks like this. What we're going to do now is take this inner trinomial and apply bottoms up. So let's rewrite this as x squared minus 5x, and then the constant term will now be 6 times negative 4, which should give us negative 24. So we'll factor this. By finding the factors of negative 24 that add to negative 5. That would be a negative 8, so we'll write minus 8, and then a positive 3, so we'll write in plus 3. But now we have to remember to divide by the original value of a. Well, the original value of a was the 6 right here, not the 18, but the 6. So we divide each of these by 6, simplify. Here we'd have x minus 4/3, and here we'd have x plus 1/2. Here's the reason why we call it bottoms up. Now we take any denominator and move it up to the position of the coefficient. So the result would be 3 times, this would be 3x minus 4, and this would be 2x plus 1. So it's a very nice method. Most textbooks don't show this, but from my experience, once students know this method, they prefer it over the others. Let's take a moment and see why this actually does work. Let's first start by solving this using the bottoms up method, and then we'll compare it to another technique and see why it is the same. So if we were going to use bottoms up for this problem, we would change this to x squared minus 4x. A times c would be a negative 12 or a minus 12. Factor this as we normally do. The factors of negative 12 that add to negative 4, that would be minus 6 plus 2. Now dividing by the original value of a, which was 4. And it's important that we do not forget we have to simplify next. So we would have x minus 3/2 and x plus 1/2. Now we perform the bottoms up, so this 2 goes to the front, and so does this 2. So the final factored form of the original would be 2x minus 3 times 2x plus 1. Now let's compare this to the method we use when the leading coefficient is equal to 1. Let's just say we decide to factor out 4. We'd be left with x squared minus x. If you factor out 4 from 3, you're left with 3/4. We can check this, but that is the same. Next, we would break it up into 2 binomial factors. The first position would be the factors of x squared. Now next, we want to find the factors of negative 3/4 that add to negative 1. Now that's a pretty challenging question, but the factors would be negative 3/2 and positive 1/2. And what I want you to notice, this step right here and this step right here are the same, except this has an extra factor of 4 and this one doesn't. But really what we're doing here is multiplying each of these binomials by 2. To see that, what I could do is rewrite this as 2 times x minus 3/2 times 2 times x plus 1/2. And what we'll notice, if I decided to distribute this 2 into the binomial factor, we would have 2x minus 3, and the second binomial factor would be 2x plus 1. So when we move this denominator up into the coefficient of x, it has the same effect as multiplying by 2, as you can see here. So the end result is the same, but this method is easier to use because over here on the right we had to deal with fractions. Now this is far from a proof of this method, but you can kind of see from this example algebraically why the result is equivalent. I hope you found this video helpful. Thank you and have a good day.